Video class, we are discussing about a problem on single channel queuing system. Let us consider a question. A small grocery store has only one checkout counter. The customer arrives at this checkout counter at random from 1 to 8 minutes apart. Each possible value of inter-arrival time has the same probability of occurrence. Means we need to distribute the inter-arrival time 1 to 8 minutes apart. All the customer is having an equal probability of occurrence. Service time varies from 1 to 6 minutes apart. Its probability value is given below. Here the service time probability value is given below. Develop a simulation table for 10 customers and take a random digit for arrival and service time. Okay, these are the random digit for the inter-arrival time and these are the random digit for the service time. Now what I have to do means first we need to find out inter-arrival time distribution table, which is going to be vary from 1 to 8 minutes apart. So usually we will write 1 to 8 minutes, 2, 3, 4, 5, 6, 7, 8. So number of customers is 8 because we are having a 1 to 8 minutes apart. So rather than 1 to 8 minutes, and each is having an equal probability of occurrence. So go for 1 divided by 8. So when you go for 1 divided by the 8, we will get as in 0.1. We will get 1 divided by, when we go for 1 divided by 8, we will get 0.12. But when you see the random digit, okay, here random digit for interval time is given as 2 digits. So we have to consider only 2 digit of result which we obtain from the 1 divided by 8. So make as equal probability. Each is having an equal probability. Write down equal probability. So once we find out the probability value, then find out the cumulative probability value. So cumulative probability value for the first customer is 0.12. For second customer is 0.12 plus next probability value 0.12 will get 0.24. So next 0.24 plus 0.12 will get 0.36. So 0.36 plus 0.12, 0.48. 0.48 plus 0.12, 0.6, 0.6 plus 0.12, 0.72, 0.72 plus 0.12 will get 0.84. So 0.84 plus 0.12 will get 0.96. This is a cumulative probability for 8 customers. Now we need to write random digit assessment for the first customer. So it should be start from 1 to 12 because we have cumulative probability value is 12. So write down 1 to 12. The second is 0.1 to 12. Next is 0.13 to 0.24. So next 13 to 24. So next is 25 to 36. See the cumulative probability value is 48. So write down 37 to 48. Next is 49 to 60. then 61 to 72, 73 to 84, 85 to 96. This is how the random digit assessment can be done for the interval time distribution table. Once again, I will repeat it. So, interval time, a customer arrived at this checkout counter at random from 1 to 8 minutes apart. Each possible value of interval time has the same probability of occurrence. So, first we have to write down this is an interval time distribution table. Write down customer number, probability, cumulative probability, and random digit assessment. 1 to 8 customer. So each customer is having equal probability of occurrence, means go for 1 divided by 8, will get as a 0.125, because here we are taking is a 2 digit of interval time is given, so we need to consider the decimal after 2 digits. So give me probability value for all the customers is having equal, so write an equal probability. Then calculate the cumulative probability. Cumulative probability for the first customer is 0.12. So cumulative probability for the second customer is 0.12 plus 0.12. 0.24. Cumulative probability for third customer is 0.24 plus 0.36, and so on. Now we need to assign a random digit assessment. The random digit assessment starts from 0.12, just 1 to what the cumulative probability value we got, that is 12, up to 1 to 12. Then next for the second customer starts from 13 to 24. Cumulative probability we got 0.24, so write down to 24. Then third customer is 25 to 36, 37 to 48, 49 to 60, 61 to 72, 73 to 84, 85 to 96. This is how we are going to find out the interval time distribution table. Next, we need to find out compute the interval time and arrival time distribution table. So I need to calculate interval time and arrival time from interval time distribution table. So when you calculating the arrival time, we need to check out how many customers we have to develop the summation table. In a question they given us 10 customer, we need to develop a summation table. So write down 10 customer, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 customers. So random digit for first customer is be always dash. So the random digit for the second customer is given as 13. In a question it is given 13. Then 27, 15, 48, 9, 22, 53, 35, 0, 2. These are the random digit which is given in a question, random numbers. Okay, random digit for the arrival times are given as here in a question. Next, we need to find out the interval time. Interval time for the first customer is attached. Here I am writing as 0. Second, we need to find out interval time for the second customer. So interval time for the second customer, see the random number 13, check out in the interval time distribution table where exactly 13 is falling. So 13 is following in this row, so we need to consider the number is 2. So interval time for the second customer is 2. Then for third customer, 27 is a random number, go to interval time distribution table. So 27 falls between these two range, 25 to 36, and its customer number is 3, write down 3. So 15 is their next random number. So check out the random number 15 is falling in this range. So you have to write 2. Next is 48. The 48 is falling under this range. So its value is 4. Write down 4. Next random number is 9. So it is falling under this range. So its value is 1. So write down 1. Next is 22. 22 is falling under this range. So its value is 2. Write down 2. Next is 53. The 53 is falling under this range. So its value is 5. So we have to write 5. Next is 35. 35 is falling under this range. Its value is 3. So write down 3. And next is 2. 2 is falling under this range and its value is 1. So this is how we are going to calculating the interarrival time based on the random number. Next, we need to calculate the arrival time. So arrival time for the first customer is 0. So arrival time for the second customer is 0 plus 2, will get 2. So and the arrival time for the third customer is 2 plus 3, 5. Then fourth customer is 5 plus 2 will get 7. Fifth customer is 7 plus 4 will get 11 arrival time. 11 plus 1 will get 12 arrival time. Next 12 plus 2 14 arrival time. 14 plus 5 19 arrival time for the 8th customer. 19 plus 3 21. So 21 plus 1 22. This is how we are calculating the arrival time for the customer. Once again I will repeat it how to compute the inter-arrival time and arrival time from the inter-arrival time distribution table. So what that question said, develop the simulation table for the 10 customer and take a random digit for arrival and service time is given in a question. So first you write down the customer number 1 to 10 because we are developing a simulation table for 10 customers. And next here we need to put a random digit number, the random digit number which are given in the question. So always remember that the random digit number for the first customer will be 0 or nothing but dash. Okay, in Excel I have written as 0. In exam, in answer sheet you have to write a dash. Okay, for second customer it is given in 13 in a question. Next 27 is given, 15 is given, 48 is given, 9, 22, 53, 35 and 2. Next we need to calculate arrival time. So arrival time for the first customer, inter-arrival time for the first customer is 0. Now we need to calculate arrival time for the second customer. So what we have to do is take a random digit 13. Go to the inter-arrival time distribution table and find out in which range the random number is falling. So a random number 13 is falling in this range 13 to 24 and its corresponding value is 2. Write down 2. Next random number is 27. Check out 27 is falling under this range. So its value is 3. We'll write a 3. Next is 15 random number. The 15 is falling under this range. So its value is 2. So I'm writing it 2. Next is 48. The 48 is falling under this range, so its value is in 4. We have to write in 4. Next is random number is 9. 9 is falling under this range, so its value is 1. So we have to write a 1. Next is 22 random number. 22 random number is falling under this range and its value is 2. So we'll write a 2. Next is 53. The 53 is falling under this range and its value is 5. So we'll write as in 5. Next random number is 35. 35 is falling under this range and its value is 3. So we'll write as in 3. Next random number is 2. The 2 is falling under this range. We'll write its value is 1. In this way, we are going to calculating the inter-arrival time. Next, we need to calculate the arrival time. To calculate the arrival time for the first customer was 0. Then the arrival time for the second customer 0 plus inter-arrival time 2 will get as a new arrival time, that is 2. Then 2 plus 3 will get as in 5. So 5 plus 2 will get 7. 7 plus 4 will get 11. 11 plus 1 will get 12. 12 plus 2 will get 14. 14 plus 5 will get 19. 19 plus 3 will get 21. 21 plus 1 will get 22. This is how we are going to calculating the arrival time. Now once we find out the arrival time, next we need to find out the service time. So service time, this is a service time distribution table. Now in a question the service time is vary from 1 to 6 minutes apart and its probability value is given below. So you have to write service number 1 to 6, 3, 4, 5 and 6. And its probability value is given in a question. Its probability value is given in a question for 1 is 0.1. For the service time for the second value is probability value is 0.2. So write on 0.2. Next one is for service time for 3 is 0.25. We'll write 0.25. Next one is 0.3. So we'll write 0.3. Next one is 0.1. So we'll write 0.1. Next one is 0.05. These are the data which are given in a question. Next we need to find out cumulative probability. So cumulative probability for the first service number is 0.1. So then cumulative probability for the second service is 0.1 plus 0.2 will get as in 0.3. So next is cumulative cumulative probability for service number 3 is 0.3 plus 0.25 will get as in 0.55. Next 0.55 plus 0.3 will get as in 0.85. Next 0.85 plus 0.1 will get as in 0.95. 0.95 plus 0.05 will get as an 1.00. This is a probability, cumulative probability value. Next, we need to assign the random digit assessment for the service number. So it will be range from 1 to 10. Then for this one, the range is 1 to 10 for first one. For second one, 11 to, we get a cumulative probability as 30. So 11 to 30. For third one is 31 to 55. Fourth one is 55 to 56 to 85. Fifth one is 85 to 86 to 95. Last one is 96 to 00, because we got 1.00 as a cumulative probability for 6 customers. So this is how we have calculated the service time distribution table. Next, we need to find out the service time from service time distribution table, because we are developing a 10 customer, means write down 10 service number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 service number, and its random number is given in a question. The random numbers are 84, 10, 24, 53, 17, 91, 79, 67, 38, 89. Okay, the random number for service time will be always begin from first service number, whereas in the random number for the interval time for the first customer will be always dash. So in a question, the random number for first service time is given as 84, second one is given as 10, third one is 24, fourth one is 53, fifth one is 17, sixth one is 91, sixth one is 79, seventh one is 79, eighth one is 67, ninth one is 38, last is 89. These are the service time given. Random number is given for the service time. Now we need to find out the service time based on the random number to the service time distribution table. Now take the 84 and go to the service time distribution table. So 84 is following under this range. So service number is 4. So I will write the service time for the first customer is 4. So next 10 is falling under this range. So its service number is 1. So I will write as 1. So next service number is 24. 24 is following under this range and its service number is 2. So I will write it as 2. So 53 is there. So 53 is falling under this range and its service number is 3. So I will write 3 here. Now 17 is there. 17 is following under this range and its service number is 2. So I will write 2. 91 is there. 91 is following under this range. So its service number is 5. So I will write 5. So next is 79. 79 is following under this range. So its value is 4. So I will write 4. Next service number is 67. 67 is following under this range. So again service time is 4. So I will write 4. 38 is there. 30 is following under this range and its service time is, the service number is 3. So I will write as 3. Next one is 89. So 89 is following under this range. So its value is 5. So I will write 5. Once we have calculated arrival time and service time, then we will go for developing a simulation table for 10 customers. So this is a final table for developing a simulation table for 10 customers. So I will write 10 customers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So next we need to write only arrival time. So arrival time we have already calculated from the table in the interval time distribution table. The arrival time is given as 0. So I will write 0, then 2, then 5, 7, 11, 12 is given. So write down 12. So 14 is there. So write down 14. 19 is there. So write down 19. 21 is there. So write down 21. 22 is there. Write down 22. So these are the arrival values which where we calculated from interval time distribution table. These are the values. Next we need to write down a service time. Service time which will be calculated from the service time distribution table. This value is 4. So write down 4. Next is 1. So write down 1. Next is 2. So write down 2. Next is 3. Write down 3. Next is 2. Write down 2. Next is 5. write down 5, next is 4, write down 4, next is 4, again write down 4, next is 3, then 5. Okay, these values we have written, which are calculated from here. Okay, then now we need to find out TSB, nothing but time service begin, TAC nothing but time service end, TCWQ means time customer wait in a queue, TCSS means time customer spent in a system, ITS nothing but idle time of the server. So time service begin for the first customer is, see the arrival time 0, so time service begin is 0. So time service end, how to calculate time service end means time service begin plus service time. So 0 plus 4 is time service end. So we got 4, 0 plus service time. Time service begin plus service time will give as a time service end 4. Now time customer wait in a queue. Initially no customer waiting in a queue. Initially the no customer idle time of the server is 0. Now time customer spent in a system. To calculate time customer spent in a system, the time service end minus arrival time, that gives us a time customer spent in the system. So 4 minus 0 is 4. This is time customer spent in a system. Next, I need to calculate time service begin for the second customer. So time service begin for the second customer, customer is arrival time is coming at is 2. So 2 is there. The server is going to be get finished at 4. Now out of these 2, which is the maximum value is there, that will become as a time service begin for the second customer. So we need to compare 2 with an 4. So maximum value is 4. So that is time service begin is 4. So time service end is time service begin plus service time will give as a time service end, that is 5. Now time customer wait in a queue, whether the customer is waiting in a queue or not. Let us see. So server is going to be finished at 4, but the customer is coming earlier than the server. So what is the difference between time service end and the time arrival time is 2. That is become a time customer wait in a queue. So means the 2 minutes the customer is waiting for the server to be finished the operation. The server is going to finish the operation at a 4 minutes, but the customer is coming before finishing the service time. Okay, so that is the difference. 4 minus 2 will get as a 2 minutes the customer waiting in a queue. So when the time customer waiting in a queue is there, automatically the idle time of the server will be 0. Now time customer spent in a system. So calculate time service end minus arrival time. So 5 minus 2 is 3. So 3 minutes the customer spent in a system. Three minutes the customer is going to be spent in a system. Correct. Yes. Then next the server is customer is coming at 5. Next customer is coming at 5. The server is going to be finishing the operation at 5. So next server is finishing the operation at 5. The next customer is coming at 5. Means both are same. So I will write time service begin at 5. So time service end is time service begin plus service time is time service end. 5 plus 2 is 7. So whether the customer is pending in a queue or not, so server is going to finish the operation at 5. At the same time the customer is coming at the 5. It means the customer is not waiting in a queue, 0. So time customer spent in a system, to check the time customer spent in a system, so time service end minus arrival time. So 7 minus 5 is 2, that is time customer spent in a system. And idle time of the server is going to finish the operation at 5, the customer is coming at the time 5, so again the server is not an idle, so we will make it as a 0. Next the customer is coming at 5, the server is going to be finished at 7, so server is going to finish the operation at 7, the customer is coming at 7. So Again, now out of these two, the both having the same value, then I will say that the time service begin for the fourth customer is 7. So time customer spend the time service end is 7 plus 3, that is 10. Time service begin plus service time is gives 10, time service end. Now we need to find out time customer wait in a queue. The customer is coming at a 7, the server is going to finishing the operation at a 7, means the customer is not waiting. Similarly, the server is also not waiting, so 0. So time customer spent in a system, so time service end is at 10, so arrival time is at 7, so 10 minus 7 will get as a 3 minutes the customer is going to be spent in the system. So next, the customer is coming at 11, the server is going to finish the operation at 10, so server is going to finish the operation at 10, so customer is coming at 11. Now we will see out of these two, the maximum is 11, so I will write time service begin is at 11 for the fifth customer. So time service end for the fifth customer is time service begin plus service time, so 11 plus 2 is 13, that is time service end. Now we need to find out time customer wait in a queue. So server is going to finish the operation at 10, the customer is coming at 11, means the customer is not going to be waited, here the server is going to be waiting. So the time customer wait in a queue is 0, the idle time of the server is 1, because the server is finishing the operation at 10 minutes, after 1 minute the customer is coming, it means that server is waiting for the customer, but not customer is waiting for the server. So idle time of the server is 1 minute, the waiting time for the customer is 0. Next we need to find time customer spent in a system. To find out time customer spent in a system, that is 13 time service end minus arrival time. 13 minus 11 will get as 2 minutes the customer is going to be spent in a system. Next, the server is going to be finished the operation at 13, the customer is coming at 12. Server finishing the operation at 13, the customer is coming at 12. So out of 12 and 13, the maximum value is at 13. So time service begin is 13. So time service end is 13 plus 5 will get as an 18. That is time service begin plus service time will give as an time service end 18. Next, the customer waiting in a queue. So the customer is coming at 12. The server is going to be finishing the operation at 13. Means the customer waiting for server to finish the operation for 1 minute. So the time customer waiting in a queue is 1 minute. So automatically the customer is waiting for the server, means the server is not an idle. So write down server idle time for the server is 0. Next we need to find out time customer spent in a system. The time customer spent in a system can be calculated as time service end minus arrival time. So 18 minus 12 will give as in 6. 18 minus 12 will give as 6. So 6 minutes the customer is going to be spent in a system. So another way of calculating is calculating the time customer spent in a system is this is time customer wait in a queue plus then service time is also given as time customer spent in a system. So next the server is going to finish the operation at 18 and the customer is coming at 14. Server finishing the operation at 18, the customer is coming at 14. The out of these two, the maximum value is 18. So the time service begin is at 18. So time service end is 18 plus service time. Time service begin plus service time, that is 18 plus 4 is 22. That is time service is going to be get ended. And that whether the time customer wait in a queue. So customer is coming at 14. The server is free at 18. Means the customer is waiting for the server for 4 minutes. 18 minus 14 will get as 4. If the customer is waiting, automatically the server is not going to be wait. So total time the customer spent in a system is time service end minus arrival time. 22 minus 14 will give as in time customer spent in a system. 6 plus 8, 8. 8 minutes the customer is going to be spent in a system. Next, the server is going to finish at 22 and the customer is coming at 19. Out of 22 and 19, which is the maximum value is there, that will become as the time service begin for the new customers. So 22 and 19. So maximum value is 22. So time service begin for the 8th customer is 22. So time service end is nothing but time service begin plus service time. So 22 plus 4 is 26 is a time service end. Next, time customer wait in a queue. So customer is coming at 19. So server is going to free at 22. Means the customer is waiting for 3 minutes. 22 minus 19 will get as in 3. So if the customer is waiting, automatically the server is not an idle. So write down, so idle time of server is 0. So time customer spent in a system can be calculated as time service end minus arrival time will give as a time customer spent in a system. So 26 minus 19 will give as a 7 minutes the customer is going to be spent in a system. So next server is going to be finished at 26. The customer is coming at time 21. So out of 21 and 26, which is the maximum value is there, that will become as time service begin for the new customers. So time service begin for the new customer is 26. So time service end for the customer is 26 plus service time. Time service begin plus service time will give as a time service and 26 plus 3 is will get 29. So time customer waiting in a queue. So customer is coming at 21. The server is going to be finishing at operation 26. It means the customer is waiting for the 5 minutes. 26 minus 21 will get as an 5. So if the customer is waiting, nothing but the server is busy. So we need to calculate time customer spent in this system. So time customer spent in a system is time service end minus arrival time. 29 minus 21 will get as an 8. 8 means the customer is spending in a system. Next, the server is going to finish the operation at 29. The customer is coming at 21. So our bit 22. The bit 22 and 29 out of these two, which is the maximum value is there, that became as time service begins. So time service begin for the next customer is 29. So time service end for the 10th customer is time service begin plus service time, that is 29 plus 5 will get as in 34. That is 34 minutes. So time customer wait in a queue. So customer is coming at 22. The server is going to finishing at 29. Means the customer is waiting for the server for 7 minutes. The customer is waiting for the server, then automatically server was busy. So write down the idle time of the server was 0. Next time customer spent in a system. To calculate time customer spent in a system, so time service end minus arrival time, that is 34 minus 22 will give as an time customer spent in a system, that is almost 34 12 minutes. 12 minutes the customer is spent in a system. This is an single channel queuing system problem.